Oh yeah, I think it's a really cool way you explain that, starting off with like how like LLMs kind of process embeddings and how like contextual meaning is kind of relative. And I think like like the analogy you presented as well with like co-reference resolution as well as like the stereotypes associated with certain pronouns. I think that's really really cool. And first of all, I kind of had like two questions. So first of all, like this one might be a little bit more straightforward, but where do you think like the stereotyping comes from within like the data and the model itself?
Yeah, so the steel tag actually come from several places that we found. So fundamentally the data that you use to pre-train those model has some bias. Yeah, because they I mean our society is biased, we need to admit, right? And then when people read the book, there will be sort of what we call reporting bias because sometimes there will be bias that people more likely to mention those majority event and then some minority event will be ignored. So that would be one type of a reporting bias. There could be another reporting bias that is in a reverse way. For example, you would likely to say there is a green banana, but you probably would not say yellow banana, right? Because yellow banana is very highly associated, and then you don't need to emphasize this is a yellow banana, right? So that will also happen, like when people talk about occupation, they would say, "Oh, there is a male nurse," but they probably would not say there is a female nurse. So this kind of reporting bias could also encode in the data. So data would be one source of a bias. But also when you train the model, usually when we training the model, you let the model trying to learn from the data. But in machine learning 101, they also teach you you need to do some regularization, right? So you don't want the model to overfeed the data, so you will add in bunch of things to make sure the model, uh, don't always just learn from the data, but also have some regularization. And in that way, you can remove some noise, and then you can let the model more generalize. But when you're trying to remove the noise in that sense, the model could also remove some minority cases because now they think they are noise. They just happen once or twice in the whole data set. So that's another source of a stereotype or bias because the model tend to remove something that they don't see very often in the data, right? So then that part we're going to amplify the bias. There's also another source of bias is that when you ask a model to make a decision, if you ask a model to generate a distribution, then that's fine. The model will say, for example, oh, nurse can be 56% male, 46% female, for example. Then that's fine because you have that distribution. But if you ask a model, in many cases, generate a discrete output, right? And then the model will force to pick a side. So even this is a 51 versus 49, the model will pick 51 as the answer, right? So then you can see that in that process, the bias could be further amplified, yeah, because even this is a slightly toward one side, the model, because you force a model to make decision at the end, right? Then you would only pick one side. Yeah, so these are all kind of bias, and then there's other bias that can be happening, like when the user uses a model, the user itself could also have a bias, right? So the bias could also propagate to the model as well.
Yeah, that was really interesting, especially when you talked about how the data, how the model can sometimes filter out noise when introducing a third party. And I was wondering if you've ever tested LLMs with non-binary pronouns and how that's worked out.
Yeah, so that's exactly I was mentioned that we have a series of work on trying to understand how the model deal with a non-binary pronoun. Yeah, so in our early paper, we basically showed that in many different applications, like machine translation, co-reference resolution, or all different type of tasks, the model in general cannot deal with non-binary pronoun well. Yeah, and it can be a very problematic. For example, in one of the project, we're trying to apply large language model to understand government administrative data. So this is a data like collect by the CDC. So when someone commits suicide or there is a homicide, usually what happens is there will be a social worker to investigate the situation and write down a report to tell basically we have a database to tell why people commit suicide or why there is a homicide happen. So that data definitely very important, right? Because then you can use that data to do some analysis, and then you can basically build up a report to the government. So then they can base on the government to see what the policy we can make to ensure those things never happen later, right? So that's basically a very important task. And the current way people do that is this researcher and social worker trying to read all these 100,000 different report and trying to find the correlation and then and basically report those things. But of course, we want AI to help that. And one particular problem there is that there are a lot of cases of suicide commitment is done by people in with a non-binary gender, right? So they can be LGBT youth. They actually have a like I forgot exact number, 3 times or 5 times more likely to commit suicide than the binary gender people. Okay, so then that is basically the background. So then as a NLP scientist, right? So I would say, okay, let's try to apply the current model to see if the model can help us to understand those documents and come up with some analysis. But what happened we find is that the model have a very strong pre-assumption that when you say there is a male and there is a partner of that male, then you will always assume that would be a female. Yeah, so then for the LGBT cases, the model will just make all the different type of mistake because of this pre-assumption. Yeah, so that is a case that non-binary gender consideration is super important here. First, the model may not be able to really recognize those new pronoun and help us to really understand those documents. And second, those kind of pre-assumption will make the model make a mistake when doing all this analysis. Yeah, and the performance can be terrible, like less than 10% correct. So basically it's useless. Yeah. So yeah, so that's yet another very important case where non-binary gender consideration is important for for those model.
Yeah, it's kind of unfortunate to hear about like the suicide rate and the mistakes that the models are making. And yeah, I think like integration of multiple genders and like non-binary pronouns is a crucial things to like language models and NLP as we strive to more like fairness and less bias. And your research on this has been a really cool topic that we explored, like how to make language models to align more with human values. And another aspect of your research that we found really fascinating was multimodal AI. So actually, like I was kind of like being a bit of a fanboy with you like before the meeting because I discovered I found out that you made Visual BERT. So I
Yeah.
actually used Visual BERT for a project a couple years back. I tried to make these glasses that can kind of understand the contextual meaning of objects and do like visual question answering and stuff. And when I found out you made Visual BERT, that was pretty cool. So
Yeah.
I'm really excited to have like, the opportunity to meet you like and talk about that. So I was just kind of wondering if you could describe what Visual BERT is to the listeners, as well as some of like the developments that have been made with it.
Yeah. So Visual was project that we developed like in 2019, 5 years ago. Yeah, so that time the bird model people are super excited about that because you can carry the contextual meaning of the sentence and then perform very well in a lot of large language model applications. So we were thinking at that time that can we also encode the vision signal into sort of visual embedding and add them to the bird model. So then you can train the model similar to the bird, and then to see if we can tie the vision signal and the language signal well. So then you can combine these two things together. So to our surprise, that the model can actually do much better than I thought at that point. Because if you think about before 2019, what the way that people train a vision model is usually you need to have a hand label all the things, right? And then you need to basically spend like $1 million to label this is a cat, this is a dog, this is something. So the issue for that is that you cannot really generalize the understanding of the object to certain degree that if this is some object that is not appear very often, you have a notation. But what Visual BERT can do is that by training on the image caption data, you can automatically align the word with the object in their representation. So if you have an image there is a accident there, and there is a car that is upside down, and there is an ambulance. And then you ask the model to basically align the captions that there is an accident happens in the road to that image. The model can actually align the word accident to the car that upside down rather than other car in the scene. You also align a little bit on the accident to the ambulance because these two things are correlate a lot in all the image and the captions. So that gives us a sense that, well, by combining vision and language model together with caption data, you already have that knowledge to align these two things. And even in a very high semantic level. So instead of just object name, but in a more high level concept, the model can align them. Yeah, in a similar thing, we find that you can align, for example, birthday to a cake, right? And then you can align several high-level things. So then start from there, we develop several different other model on the row. So we have a model called GLIP, which is a variance of the clip model. So you probably some people here maybe know the clip model. So in the clip model, people align the image with the caption. So then you can use that to basically give a very give a caption with some unusual object. The model can also find the corresponding image. But we're trying to do that not only in the image and the caption level, but we also do that in the phrase level and the object level. So not only just capture the image and caption, but you can actually capture that specific items in the object in the image with the phrase in the description. So why we want to do that? Because we want to work toward a even more ambitious goal is that can we teach the model like the way we teach the kids to understand the new concept, right? So if you think about how you teach a kids, you are not going to show them 10,000 of image of a cat to say this is a cat and this is a dog. You're going to give them some more general description, right? Or the cat has a tail, the cat has this type of ear, you can describe those general things, or even just scratch a little bit and the kids can understand that very nicely. Right. And then if you want to specify that, there are two cats, there's a white cat, there's a black cat, then you can just specify then using a language the key can recognize by combine those description together. Right. So if you want to let the model to do the same thing, the model need to be able to understand the thing in a more detailed level, in the face level to know all these composition. Also, you need to let the model to recognize those novel objects, right? So then that is our more recent work that published in NeurIPS that we actually now can do that. You provide the descriptions of the object. For example, I say, I want to recognize a tool that has a round head and it has a handle, and the model can identify the mallet in the image. Yeah, and then you can even say that I want to recognize the crown that is kicking a soccer, and the model can identify that crown instead of the other crown maybe making a balloon or something. Yeah, so that's the kind of level that we want to do that. Actually, you can just provide a description, and the model can base on this description to recognize the object you refer to.
Yeah, that's super interesting. And I like how you mentioned GLIP earlier. Armand and I were discussing before the session about how you used your work in the CVPR 2023 challenge with GLIP, and you created your Desco model and your success that you met with Desco. And Armand and I previously used to use CV a lot with localization and detection for our robots when we competed in the first tech challenge. And so we were really fascinated just in general about the work that you've done with CV. And so we were wondering if you could speak a little more to what the challenge was that was CVP R 2023 and your thought process behind coming up with such a model like Desco.
Right. So that challenge is called the Army Labels challenge. And the challenge is feature that you want to recognize the object with some specification. So basically like the description I was saying that you want to recognize the crown, but there may be multiple crown in the image and you want to recognize that specific one. Or if there are, multiple donuts on the table, you want to recognize the one with the red sugar glare on the top or something. So you want to recognize that specific one. Yeah, and they also some novel objects like maybe they ask you to recognize the paramedic, for example. So basically the model never see that specific object name, but you can based on the costume, all these things to recognize that specific person. Yeah, so that is a challenge. And we didn't actually prepare for that challenge. We prepared for the desk code paper, but at some point, the challenger organizer tell us that they have this new data set. We say, oh, that's great. That's exactly the thing that we want to do in the desk code. Yeah, so we participate in that challenge and then apply uh our method, and then it actually performed very well. Yeah, and I can speak a little bit about the thought process behind the desk code. So after we publish this GLIP paper that can recognize align the phrases with the object in the image, we find that the model already have a little bit capability to use a description to recognize the objects. So for example, if you ask a model to detect the ray fish, right? So the ray fish is a fish, but it looks like flat and round, so it's not typical type of fish. So if you just say recognize a ray fish for me, the model can recognize some of the ray fish, but not all, and also make a lot of mistake. But if you say I want to recognize a ray fish, but and tell them the description, the ray fish is type of fish that is flat and round, and the model can actually do much better. So that gives us a kind of a motivation. Oh, the model, even the GLIP model doesn't train in that a specific way. It can already do this type of description-oriented recognition. However, when we apply that model to the text like I described, based on the description or based on the specification to recognize the things, it doesn't do very well. And then we find that there are two main reasons. So one is that model like GLIP, they train with a lot of object name, and the model will take a shortcut. If the model already see you mention a cat or dog, you just know what is cat and dog. It doesn't need to read the description, right? So even you put the description there, the model will tend to ignore that. Yeah, because most of the data they train on just need to know this is cat and dog is enough to recognize the thing that you mentioned. So that's one shortcut, and then that causing a lot of issue. And so to mitigate that issue, what we do is we replace like cat and dog to animal, right? So you basically replace all those specific name with a more high level categorical name. So then the model will need to really read the description in order to recognize the things. And the second issue is that people don't usually give you a description or definition for some objects when you are communicating with each other, right? You will not say, "Oh, today I meet a cat, and the cat has a tail and has a 2 ear," right? That's a kind of a thing that everyone knows, so you don't really mention that when in your communication. So to deal with that issue, we use a large language model like ChatGPT to generate a bunch of a description of real objects and append those things into the data. So now the model actually fine-tune on certain data that based on those description to recognize the object. So then you are going to learn how to connect these two things together. But even more, we find that if you just give this, the model will also sometimes just take a shortcut. When you see this, for example, a tail, then you already can identify that distinguish cat and people, right? So then you basically will not read the rest of a description. So what we further do is that we also generate description of a confusable object. So to challenge the model to base on two description, only different is slightly subtle detail to recognize the object we mentioned. So in that way, we really can build a good model that based on the detail of those description to recognize the object.
Yeah, that's awesome. And we're running a little bit low on time, so we're gonna kind of cut to like the last couple of questions. But are there any directions you're currently exploring or works that we can look forward to from you in the future?
Yes, so I think the current most exciting project to me is that how to incorporate the reasoning of a large language model to deal with those trustworthy problem and also this multimodality problem. So basically group all these things I was talking about together. Yeah, and then there are a lot of agentic tasks that people are interested in. For example, apply the large language model to help you to solve some tests when you use a website, or when you're using the you know the home smart home device, right? And then all of them would require a certain trustworthy component, because you want to make sure the model perform the test well in the right way. And also you want to explain to the model in a high level, like you explain to your secretary, or your person, how to perform certain tests, right? So then you would need to based on those kind of language description, and the model need to learn what is a guideline, policy, constraints, and then use them to perform certain tasks. Yeah, and the test can be multimodal. So you need to also understand the visual world. You need to be able to incorporate all this information together with certain sort of reasoning, then to perform the action. Yeah, so that's kind of my most exciting interaction that I would like to do. Yeah.
Yeah, that's really cool, and we're really excited to look forward. I mean, we're really excited to see what you guys do with that. While your professional achievements in AI and ML are well documented and truly astounding, we'd love to know what you enjoy doing in your free time. Are there any hobbies or activities that you are passionate about outside of your work?
Uh, Other hobby? Yeah, so I have a daughter, 3 years old. Yeah, so now my current hobby is play with her and then see how how the 3 years old kids is different from the LLM, right? So that was a lot of a funny thing that we discovered. So you may feel LLM is smart, right? So then you can do a lot of things that even college student cannot do, but you also cannot do a lot of things that even 3 years old can do, right? So that's a very interesting observation, like how the human and the smartest LLM, how they are different, how they are the same. Yeah. So a lot of inspiration of the research actually come from like play with my daughter, for example. Like I see I can give a very high level description, my daughter can really understand it, and then very soon they recognize a new object. Even you just give her 2 or 3 cases, she know that. But LN cannot do that. So that's a kind of a funny thing that when we observe how the keys grew and how the LN is trained.
Yeah, that's really, really cool. And we really appreciate you coming on today to the Neural Network, and our listeners definitely appreciate all the insights you had about large language models and computer vision, and all your work and what you've done for the AI community. So thank you again for coming on to the Neural Network.
Yeah, thank you.